6.6, phase shifts. Phase shifts is the movement of your sine, cosine, tangent graphs on the horizontal axis. So we have the vertical shift, which we have seen, which is on the vertical axis, moving your midline of the graph up and down, where the phase shift or the sinusoidal shift is the left and right movement. We're not going to be graphing these right now. We are just going to work on finding amplitude, period, and phase shifts. And then we'll also be looking at how to identify a vertical shift again. So amplitude, period, vertical shift, review. Phase shift is new, but it has the same idea as the transformations that you guys have been looking at since Math 1, with all the other different types of functions that you guys have seen. So I have all three formulas here for sine, cosine, and tangent. Your amplitude is still your leading coefficient, tells us how high that graph is going to be from the midline. Your omega is the coefficient of x, and that still helps us find the period, which is 2 pi over omega. But remember, for tangent and cotangent, your period is pi over omega. Those two are periodic over pi instead of 2 pi. Now for your sinusoidal shift, your phase shift. To find that, it is phi over omega. Well, phi is the value that is being added or subtracted from your x value. The easiest way to find your phase shift: take the inside of your parentheses, that whole term inside, the whole value, all terms, and set it equal to 0 and solve for x. We get the phi over omega by having omega x minus phi set equal to 0. You add phi. Sorry, my phi's always look kind of weird. Omega x equals phi, divide by omega, and your x is phi over omega. So on a graph, you would actually graph, again, we're not going to do this right now. Today is just let's find the phase shifts. On a graph, you would graph the very base, whatever it is, your amplitude and your period. You'd graph those. Then you would apply the phase shift. So if it was a plus pi, you would move your graph to the right, pi. If it was minus pi, you would move your graph to the left, pi. But that's going to be another day. Again, our focus right now is let's just find the phase shift. So to add some review here, I do want us to find amplitude and period. So let's start with our amplitude. I know you guys don't have these notes yet. Pause the video, write stuff down. Pause the video, write stuff down. Don't try and write at the same time as I'm talking if you're trying to understand this. If you think you got it, fine. Otherwise, keep using the pause button. So my amplitude is 3, which comes from my leading coefficient. To find the period, 2 pi over omega. Your omega is 2. So 2 pi over 2. So my period is pi. The 2's canceled. They became 1. Now to find my phase shift, and I will abbreviate phase shift with the PS. So my phase shift, I take my inside, my 2x minus pi, and I'm going to set this equal to 0. So I'm going to start by adding pi. So 2x equals pi. Then I'm going to divide by 2. So my phase shift is x equals pi over 2. Since it's positive, my graph would go to the right. So depending upon how you scale your graph, when we scale our graph, we always go 1, 2, pi, 1, 2, 2 pi, which would put pi over 2 right there. So that would be the shift. Wherever your points are, that's how much they're going to move to the right. So we would graph this sine graph, then with the amplitude of 3 and a period of pi, then I would shift everything to the right pi. Again, that's going to be another day. Okay, let's move on to this next one. My amplitude is 2. Yes, my coefficient is negative, but my graph will reflect the negative. This right here means my graph will actually start at -2 instead of +2, but my amplitude is still 2. My period, 2 pi over omega, which is 2. So another period of pi. Now let's find the phase shift. 2x minus pi over 2 equals 0. I'm going to start by adding pi over 2. So it'll cancel there. 2x equals pi over 2. Now there's two ways you can do this. You can multiply by 2 to get rid of your fraction first. I know some of you really dislike working with fractions, so that'll cancel. You're adding work here. 4x equals pi, divide by 4. Your phase shift is going to be pi over 4. So you graph this cosine graph with an amplitude of 2, period of pi, a negative coefficient. Then you would move everything to the right, pi over 4. Now, another way that you guys can do this work without multiplying by 2 and adding that extra step, the natural thing here is, I'm going to divide by 2. Well, this is the same as 2 over 1, so I'm going to multiply by the reciprocal. You're taking pi over 2 and we're cutting it into 2. So if I take pi over 2 and I cut that into 2, I now have sections that are pi over 4. My sections are pi over 4 in size. That would be my phase shift. Hopefully that helps with that explanation of the fraction. If not, multiply by 2, get rid of your fraction. All right, next one. Hold on a second, I need to pause real quick. All right, so next one, amplitude is 2, period, 2 pi over omega. Well, what's the value with our x here? Oh, it's 2 pi. That means our period, 2 pi divided by 2 pi, is 1. So if I were to graph this, I would still graph it on my radian coordinate plane with pi over 2, pi, 3 pi over 2, and 2 pi. But I would convert those into decimals so then I can figure out where 1 is. This 1 here at the end tells me that my graph is going to be moved down 1. Again, I would apply that to my graph before I do a phase shift, but you could also apply that after the phase shift. All the shifts that take place can be done separately or together, but this would make my midline, instead of my midline being on my x-axis, my midline is going to be at -1. Now we need to find our phase shift. So 2 pi x minus 4 is going to equal 0. Move the 4. 2 pi x will equal +4. Divide by 2 pi. 2 pi's on the left side will cancel. So I have 4 over 2 pi. The 4 and the 2 will cancel. The 2 divides into 4 2 times, and I'm left with pi in the denominator. So there's my phase shift. Again, I would want to convert that to a decimal so I can figure out about where that phase shift would end up being. All right, that takes care of our first example. We have one more example to go. Now, on this one, you're given the amplitude, the period, and the phase shift, and we're going to use that information to create a sine graph. So write the equation of a sine function that has the given characteristics. So we have y equals, if you remember when we did this so from, I think it was 6.4, the cosine video, it's example 3 and 6.4, I do go over how to write the equation of a sine graph or a function given some information. So if you did watch that video, this shouldn't be too bad. The only extra part is the phase shift. So the general form of a sine function, plus or minus the amplitude. Remember, amplitude is always represented as a positive number because we're talking distance. But it could come from a negative or a positive coefficient. So we need to keep that in mind with the plus or minus. Then it's sine omega x. Then it's going to be minus your phi. So we have to find three things. Amplitude. Let me use a different color. Amplitude, omega, and phi. Those are the three things that we do need to look for here. So let's see. Amplitude. We're given the amplitude. Here's our amplitude. So I'm going to plug in plus or minus 2 sine. Now omega comes from, or let's think of what omega helps us find. Omega helps us find the period. So I'm going to use my period here. We need to remember period is 2 pi over omega. I can switch these two, and omega is 2 pi divided by the period. So what's our period here? Our period is pi. The pi's will divide out and become 1, and I'm left with 2. So my omega is 2. So this will be 2x. Now we need to find phi. And if we remember from the notes at the beginning, I'll go back there. Your phase shift is phi over omega. So coming back here, I'm going to use the phase shift. Phase shift equals phi over omega. Well, I know the phase shift. Phase shift is 1/4. I'm looking for phi, and the omega we just found is 2. So here I want to get phi by itself, so I am going to multiply both sides by 2. And 2 times 1/4 is 2/4, which becomes 1/2. That's your phi. So the 1/2 is positive, so when I plug it in, I bring down the negative, and then 1/2. There's your equation. You do have to understand, though, where the amplitude, the period, and the phase shift are coming from in order to write the equation of the sine graph. All right, last one. Go ahead and write this down. These are the three things I'm given. So I'm going to start plus or minus amplitude, sine omega x minus phi. Amplitude. We know the amplitude. So plus or minus 3. Sine, let's find omega. Omega comes from, omega helps us find the period. So I can take the period, which is 3 pi. Omega is 2 pi over the period. So 2 pi over 3 pi. Now here, your pi's cancel, and you're left with 2/3. That's your omega. Now we need to find, hold on, let me get that real quick. All right, so now I need to find phi. From the last example, our phase shift is phi over omega. We know the phase shift, it's negative 1/3. We're looking for phi. We know omega is 2/3. So the denominator is 2/3. So I'm going to multiply both sides by 2/3. Cancels here. When you multiply fractions, you multiply numerators and denominators. 2 times negative 1 is negative 2. 3 times 3 is 9. That's your phi. So I bring down the negative, but then phi is negative 2/9. So that will become a positive. So I have y equals plus or minus 3 sine 2/3 x plus 2/9. And that's my equation for that sine graph. I hope this helps and you'll be able to work on your 6.6 assignment. Again, we're not graphing right now, so you're just finding amplitude, period, phase shift, and then writing equations given those three things. We'll look at graphing later. Questions, be ready with them tomorrow in class.